If you've been judging an AI agent by one question, is it GPT, Claude, or Gemini, you're only seeing half the picture. In a real agent system, the model is mostly responsible for thinking. The thing that turns that thinking into an executable, controllable, and recoverable task process is the runtime. Once you understand what the runtime actually manages, you stop asking which model? And start asking, can this system reliably finish the job? In OpenAI's Agents SDK documentation, the agent and the runner are described as helping manage turns, tools, guardrails, handoffs, and sessions. So the runner isn't just calling the model once. It's managing the complete execution process of an agent task. A useful mental model is this: the runtime is the project manager inside the agent system. The model is the smart employee, and tools are the computer, browser, database, or video editing software in that employee's hands. Without the project manager, even a smart employee can jump around, lose their place, mishandle tool failures, repeat work, take risky actions, or fail the task and still not be able to explain why. The runtime is what keeps the whole process under control. The first big shift is this: a runtime doesn't manage a single answer. It manages a task. A normal chatbot flow is simple. The user asks one question, the model gives one answer, and you're done. But an agent is trying to complete a goal over multiple steps. If a user says, "Help me make a 60-second AI explainer short video," that can involve understanding the topic, generating an outline, writing the voiceover script, generating the storyboard, creating image prompts, generating images, generating narration, generating subtitles, composing the video, quality checking, and outputting the final result. If a step fails, like image generation, the system may need to revise the prompt and retry. And if the agent wants to publish the video, it may need to pause for user confirmation. That's why one agent run is not equal to one model call. OpenAI's documentation explains that a single runner run may include one or more agents, multiple LLM calls, tool calls, and even a handoff to another agent. What the runtime manages is how all those steps move forward, from the moment the user gives a goal to the moment the system completes the task. To do that, the runtime manages the agent loop. The core loop is: the model thinks, proposes the next action, the runtime executes that action, a tool returns a result, the runtime feeds that result back to the model, and the model decides what to do next, repeating until the task is done. OpenAI's runner reference describes this loop: call the agent, if there's final output, stop, if there's a handoff, switch agents and continue, otherwise execute tool calls and then loop again. Hey, race, what that looks like in practice. The user says, "Help me research a technical framework and summarize whether it is suitable for me." The model might decide it needs to search first, but the model itself doesn't browse the web. The runtime sees the model wants a search tool, executes the search, and passes the results back. Then the model might decide it needs the official documentation, so the runtime calls a web page reading tool. Only at the end does the model produce the summary. The key idea is, the model proposes what it wants to do, and the runtime decides whether it can be done, how it should be done, and what happens next after it's done. Tools are what turn an agent from something that can talk into something that can act. Without tools, the model can only say, "You can go search for it." With tools, the agent can actually search, read files, run code, query databases, generate images, and compose videos. OpenAI's tools documentation groups tools into categories like hosted tools, function tools, and agents as tools, but the core point is the same: tools are how agents take action. But tools aren't executed directly by the model. Usually the model only outputs intent, like, "I want to call the search tool," and the keyword is agent runtime. Then the runtime has to turn that intent into a safe, valid action. It needs to confirm the tool exists, validate parameter format, check permissions, evaluate risk, decide whether it needs human confirmation, handle timeouts, decide on retries, manage overly long results, and package the output back to the model in a usable way. For example, if the model says, "I want to delete this folder," the runtime can't just do it. It should check whether deletion is allowed, whether the task truly requires deletion, whether the folder is within an allowed scope, and whether user confirmation is required. In a truly safe agent system, the model cannot directly control the world. The runtime is the gatekeeper for tool calls. Next, the runtime manages state, meaning where the task has reached. In multi-step work, the system has to know what step you're on, what's already completed, what artifacts have been generated, what failed, and what should happen next. Google ADK documentation uses a session to track a specific conversation thread, and that session contains event history and state. Session state acts like a scratchpad for task progress, user preferences, temporary data, and more. For a short video task, state might look like this. The topic is Sandbox Explainer. Script status is completed. Image status is running. Audio status is pending. And compose status is pending. That's much more reliable than hoping the model keeps it all in its head, because context can get long, details can be missed, and misunderstandings happen. The reliable approach is that important state is stored by the runtime in a structured system, and the model reads only what it needs in the moment. And that connects directly to context. Before each model call, the runtime has to decide what the model should see, which history, which tool results, which state, which files, which long-term preferences, what needs summarizing because it's too long, and what shouldn't be shown at all. This is the context builder idea, and it matters because output quality depends heavily on the context the model sees. If the task is generating an image prompt, bad context is basically, here are all chat records, all scripts, all images, and all error messages, figure it out. Better context is scoped and structured. Current task, generate an image prompt for the third storyboard shot. Storyboard content, a program working inside a restricted safe area. Unified style, a light-colored, hand-drawn whiteboard style. Aspect ratio, 16:9. Forbidden items, no complex background, and no unnecessary text. The runtime doesn't dump everything into the model. At each step, it provides just enough information, clearly structured and relevant to the current task. The runtime also manages events, which makes the process less of a black box. Without events, it feels like, start making the video, and at the end you hear succeeded or failed. With events, you can surface progress, task started. Script generating. Script completed. Image 1 generating. Image 1 completed. Narration generating. Narration completed. Video composing. Composition failed due to a subtitle timeline error. Retrying. Composition completed. Task completed. And an event isn't just a normal log line that says what happened. It's more like this: a key fact happened, and the runtime needs to react to it. When something like script completed occurs, the runtime might save the script, update state, notify the frontend, trigger the next step like generating a storyboard, and write into a trace for later review. The point is that when key steps happen, the runtime can catch them, process them, and move the task forward. Once an agent can call, tools, safety, and approval have to be part of the system too, and that's also on the runtime. Tools can do dangerous things: deleting files, sending emails, publishing videos, modifying databases, executing shell commands, calling high-cost APIs, or deploying code. Those can't happen just because the model wants them to. OpenAI's guardrails documentation also notes that tool guardrails only apply to function tools, and handoffs don't completely go through the same tool guardrail pipeline, which is a reminder that safety can't rely on only one mechanism. It has to be designed holistically at the runtime layer. A practical approach is to classify tools by risk level. Low-risk tools can run automatically, like reading public information, generating drafts, or calculating text length. Medium-risk tools can be constrained and audited, like writing files, batch-generating images, or calling paid APIs. High-risk tools should require human confirmation, like publishing content, sending emails, deleting files, or modifying databases. And forbidden tools should be blocked directly, like accessing private paths that shouldn't be accessed or executing dangerous commands. Prompts can try to persuade the model not to act recklessly, but the runtime is what can actually block dangerous actions. The runtime also manages failure, retry, and recovery because real systems always fail. Model requests timeout. Tool APIs hit rate limits. Image generation fails. Video composition fails. File paths don't exist. Networks disconnect. Servers restart. If the runtime is poorly designed, one failure forces you to start everything over, even if the script, images, and audio were already done and only the final composition failed. That wastes time and cost. A better runtime uses checkpoints. When the script is completed, save it. When images are completed, save them. When audio is completed, save it. And if composition fails, retry only composition. It also distinguishes error types. Network timeouts can be retried. A 429 rate limit might require waiting, then retrying. Parameter errors shouldn't trigger blind retries, they need fixes. Insufficient permission should stop and notify the user. Safety risk should be blocked directly. User cancellation should terminate the task. A production-level runtime identifies the failure type, retries when it makes sense, saves state when it can't proceed, asks the user when user handling is required, and resumes later from a checkpoint. The runtime also manages streaming, so users can see progress while the run is happening. If a task takes 2 seconds, that's fine. But if it takes 1 minute, 3 minutes, or longer, the user needs feedback. OpenAI documentation notes that streaming uses the same agent loop and state strategy. The difference is that you consume events during the run to show updates. For video generation, you might surface, understanding the topic, generating the script, generating image 1 out of 6, generating narration, composing the video, quality checking, video completed. This visibility isn't decoration, it tells users the system isn't frozen, helps developers see what's stuck, and makes failures easier to locate. Finally, the runtime manages trace and evaluation so problems can be reviewed later. If a user says, "This agent made a mistake," you can't just inspect the final output. You need the process, what context the model saw, why it called a tool, what parameters it used, what the tool returned, whether it retried, whether safety rules triggered, which step took the longest, which step cost the most, and why the run ultimately failed. OpenAI's run result documentation also mentions that guardrail results are accumulated in a run, which helps record decisions, save metadata, or debug why a run was blocked. With Trace, you can debug and you can optimize by changing prompts, models, or tool schemas and rerunning the same task to see what improves. To lock it in, use a restaurant analogy. The user is the customer. The agent is the chef. Tools are the pot, knife, oven, and ordering system. State is the order status. Events are progress messages like order received, cooking, missing ingredients, and served. Guardrails are food safety rules. Trace is the kitchen surveillance footage and order records. And the runtime is the restaurant front desk plus the kitchen dispatch system. Without the runtime, the chef may be capable, but the restaurant is chaotic. With the runtime, the system knows what started, what step it's on, which tools are allowed, which actions need approval, where it failed, whether it should retry, whether it finished, and how to review what went wrong. The model decides what it wants to do, tools actually do it, and the runtime decides whether it can be done, how to do it, how far it has progressed, what to do if it fails, how to show progress to the user, and how to prove it was done properly in the end. In one line, the runtime is the project manager and operating system of an agent system. It doesn't make intelligence smarter, it makes it executable, controllable, recoverable, and observable.